Okay, so we're going to be graphing quadratics, and the graph of a quadratic is a parabola, which is a U-shaped graph. This is the standard form, ax squared plus bx plus c, and you're looking at a few parts to see what the graph is doing right away. You can look at the a, and if that a is greater than 0, then the parabola is going to open up. And basically what that means, if that a is positive, then it's opening up like this. If that a is negative or less than 0, then what's going to happen is it's going to be flipped and it's going to be opening down. The a could also make the graph wider or narrower than the parent function y equals x squared. And we're going to graph that parent function here in a second. But let's first talk about when it would make it wider or narrower. If the absolute value of a, so that means not looking at the negative sign, if it's greater than 1, then it's going to make it more narrow, and what we're going to call that is it's going to stretch it. And if it's less than 1, basically between 0 and 1, or fraction less than 1, it's going to make it wider and it's going to compress the graph of the parent function. The vertex, we're going to talk about the vertex, and the vertex is the highest or the lowest point on the parabola. It's also called the maximum or the minimum, depending on if it's the highest or the lowest. Okay, so for one that's opening up, that's going to be the vertex where it turns, and that would be a minimum, where if it's opening down, the vertex would be a maximum, because it would be the highest point in that case. And the axis of symmetry is a vertical line passing through the vertex. So to find the vertex, you're going to use the negative b divided by 2 times a. And that also gives you the axis of symmetry. But the axis of symmetry is a line, so you need to give me the equation of that vertical line. It's going to be x equals whatever that x value of the vertex is. Okay, so on to the first example, and we're first going to do the parent function. So this is the most basic quadratic function. It's just nothing's being multiplied, nothing's being added or subtracted, it's just x squared. So we're going to plug in some x values, -2, -1, 0, 1, and 2, to get the y values. When I plug in -2, I get -2 squared, which is 4. When I plug in -1, -1 squared, which is 1. When I plug in 0, it's 0, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I'm going to plot those points. 0, 0, -1, +1, -2, +4, and then +1, 1, and +2, 4. And then I draw the parabola. Now remember, it's not a V, it's more of a U-shaped. It has a curve here at the end, at the vertex, and that's going to be my parabola. The axis of symmetry is x equals the x value of the vertex, which is 0. This is the vertex at 0, 0. So everything else is going to look like this, just slightly different. So here's the first example. Let me give you the steps first of all. Okay, so here are the steps. I first need to find the vertex. So in order to find the vertex, I'm going to find x equals -b over 2 times a. So my b is negative 8. 1 second. Negative b over 2 times a. So my b is negative 8. So when I do negative 8, that's going to become a positive 8. And then 2 times a, my a is 2. So I have positive 8 divided by 4, which is 2. So my x value of the vertex is going to be 2. And then I'm going to have to find my y value of the vertex. Well, to find my y value of the vertex, I'm going to plug in my x value. So I have 2 times 2 squared minus 8 times 2 plus 6. So follow your order of operations. I first need to do my exponent, so that's going to be 4. So 4 times 2 is 8 minus 16 plus 6. This becomes negative 8 plus 6, which is negative 2. So I have my vertex at positive 2, negative 2. And before I did this, I should have said right away which way it opens. It's going to open up because this a term here is positive. The axis of symmetry is x equals positive 2. And to graph it, so I'm going to graph my vertex first at 2, negative 2. I have my axis of symmetry. At x equals 2. And I'm going to plot some other points. To get the other points, I'm going to make that chart just like we did before. I have my vertex in the middle. 2 points less than my vertex is when x is 1 and when x is 0, and then when x is 3 and when x is 4. So to plug those points in, I don't have to use all of them because this axis of symmetry is symmetrical. I'm only going to plug in one side. So when I plug in 1, I'm going to do the work over here. I have 2 times 1 squared minus 8 times 1. Oh, let me find a better spot. I'm going to erase some of this. Okay, so I erased the work for the vertex, and I'm going to do this work here. So I have 2 times 1 squared minus 8 times 1 plus 6. Square the 1 first, that's 1. Times 2 is 2. Minus 8 plus 6. So negative 6 plus 6 is equal to 0. So when x is 1, y is 0. And when x is equal to 0, I get 2 times 0 squared minus 8 times 0 plus 6. Well, that's going to make this one 0, plus 6, so that's going to be 6. And what happens on the other side is they're going to reflect. So it's going to be 3, 0, and 4, 6. And then plot those points. So you plot the points and put them in, and there you go. And because the a is greater than 1, what this graph is doing from the parent function is it's getting stretched vertically, which means it's a little more narrow, which is why it's a little more narrow. Here's one for you to try on your own. Pause it. I'm going to give you the answer here in a second. Okay, so here's what it should look like. The biggest thing to pay attention to is when you plug in the x value. So you found x to be 1 for the vertex. When you plug that in here, you have to follow your order of operations and square the x first. You're only squaring the x, and then you're applying that negative out in front. That negative is really a negative 1 that is the a. So it's negative 1 times the x squared is what it means. So you have to square it first, then multiply it to the negative 1. And the same thing happens here when you do it there. Okay?